Hello students, welcome back to today's class on comparing quantities using proportions. Previously we discussed what is a ratio, what is a proportions. Let's have a small recap of that, what is a proportion, and then we'll try to apply lot of applications on proportions. That is what we're going to do, that is comparing the quantities using proportions, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So what is the first one we're going to discuss about is a ratio, which we have already discussed in the earlier classes. We discussed about proportion as well. Okay, so if the ratio of A and B is equal to the ratio of C and D, if the ratio of A is to B and C is to D are equal, we say that they are in proportion. Okay, we say that they are in proportion. This is represented as A is to B equal to C is to D, or A is to B, E is to C is to D. We read this as A is to B is as C is to D. We read it as A is to B is as C is to D. Okay, so A is to B is proportionate to C is to D. A is to B is proportionate to C is to D. Right? So that is what we discussed about proportions, and you can see here. Here we are having out of 3 balls, 1 is yellow and 2 is blue. 2 are blue, and out of 6 balls, 2 are yellow and 4 are blue. So if you try to find the ratio of yellow balls, here it is 1 by 3, here it is 2 by 6. Both are same. We say these two are in proportion. Right? And what else we have discussed? Right? How to test, how to find whether numbers are in proportion. The ratio should be equal. Just we discussed that, right? A is to B and C is to D. The ratios should be equal. So, are 3, 5, 15, 9 in proportion? The question is 3, 5, 15, 9. Are they in proportion? How to find that? So, let us try to find what is 3 is to 5 and 15 is to 9. If these two ratios are equal, then we can say that they are in proportion. 3 is to 5, you cannot further change that. 3 is to 5. 15 is to 9, I think we can cancel with the 3. 15 is to 9 is nothing but 15 by 9. 15 is to 9 is nothing but 15 by 9. If we divide with the 3, you can get that 5 is to 3. And we can easily say that 3 is to 5 and 5 is to 3 are two different ratios. There is no comparison, there is no equality between these two. So we can say that they are not in proportion. But if the same question is asked like this, are 3, 5, 9, 15, are they in proportion? The question is, are they in proportion? Then you need to check 3 by 5 and 9 by 15, and you need to check whether these two are equal or not. Yes, these two are equal because 3 3s and 3 5s. So both 3 by 5s are equal. We can say that it is correct. Okay, next one. Find the missing terms. 15 by 18 is equal to some value by x is equal to 10 by some value and some value by 30. So how to get these values? How to get these numbers? They are equal. That means they are in proportion. So if let's say this is x, let us say this x, 15 by 18 is equal to x by 6. I think we can cancel with 3, right? 3 5s and 3 6. So 5 by 6 equal to x by 6. So you can say that directly x equal to 5. So this value is equal to 5. Let's take this as y and compare the first and the last. We can say 15 by 18 is equal to 10 by y. So now again you need to calculate properly to get the answers. So 2 5s, sorry, not 2, we cannot cancel with 2. Let us leave like this. Okay. So let me cross multiply. 15y is equal to 18 into 10. So 15y is equal to 180 and y is equal to 180 by 15. And if I am not wrong, 15 12s are 180. Let me check that. 15 12s, 5 2s 10, 2 1s 2, 3, 5 1s 5, 1 1s 1. That is 180. 15 12s is 180, right? So this is equal to 12. Y value is equal to 12. In the same way, we'll go for one more value. Let us take this value as z. 15 by 18 is equal to z by 30. So how to calculate this one? Cross multiply, or you can cancel with 6 in the denominators. Okay, 6 3s and 6 5s, and 3 1s and 3 5s. So 5 is equal to z by 5, and you'll get z is equal to 5 into 5, which is a 25. Z is equal to 25. X value, the very first blank is 5, then 12, and then 25. So simply just equate all the ratios. Equate all the ratios, your answer will be done. Okay, moving forward. So one more question. So I'm not going to do this. I'm just giving you a hint. Just take this x, equate these two, take this y, equate these two, take this z, and equate the first and the last. You will get your answer very easily. I'll just solve one, maybe the last one. Okay. 45 by 21 is equal to z by 35. I know 7 3 is 21 and 7 5s are 35. So 3 1s and 3 15s. So z is equal to 15 into 5 is 75. So 45 by 21 or 75 by 35, both are same. 45 by 21 or 75 by 35, both are same. Okay, so let's try to move forward with the next one. Once again, missing terms. Okay, 39 by 45 is equal to x by 10 is equal to 9 by z, 9 by y equal to something with the 35. I think the same question maybe. Right, no. Okay, so please try to solve that once again. Okay, so take this as x, compare, equate these two, y, equate these two, z, and equate the first and the last. You will get the answer. Very straightforward. Let me do the second one. Okay. So 39 by 45 is equal to 90 by y. So cross multiplication, 39y is equal to 45 into 90. So y is equal to 45 into 90 by 39. Can we cancel with 3 maybe? Maybe 3 30s and 3 13s. So 45 into 3, 135. 1350 by 13. 1350 by 13. So I don't think we can cancel anything. If yes, please try to reduce that into lower terms. That is the value of y. Right? If there is any calculation mistake, so please check that. Maybe it's not 39, maybe 30. I think so. It will be more easy if we have 30 here. Okay. Whatever it is. So this is how we can try to find the answers. The next one. Now the next important thing is the compound ratio. We discussed, what is a ratio, but not what is compound ratio. Again, when we're discussing about compound ratio, we have two different ratios. You can see here. Two simple ratios. So two ratios. We have two ratios, not one. Two simple ratios are expressed in the form of single ratio as the ratio of product of antecedent. That means the very first value. If you have A is to B, A is the antecedent to product of consequence. The next part is the consequent. Okay, AB is there, CD is there. So if you can multiply AC and BD, we say that newly formed ratio is called the compound ratio of the two simple ratios. The name itself says that compound. Generally, compound is used for a mixture of elements together or mixture of things together. Here, compound, there are two ratios. We are going to mix them into one. So that is the reason we say that it is a compound ratio. Okay. So A is to B and C is to D are any two ratios, and the corresponding compound ratio. Then the compound ratio is A is to D, AC and BD. AC is to BD. AC is to BD, right? So moving ahead, we have one question here. If 2 is to 3 and 5 is to 6 are ratios, find the compound ratio. If 2 is to 3 and 5 is to 6 are ratios, find the compound. Compound 2 into 5 is 10, is to 3 into 6 is 18. 2 into 5 is 10, is to 3 into 6 is 18. 10 is to 18. You can leave like this, or you can try to simplify further. So you can write this 10 is to 18. You can write this as 10 by 18. You can reduce that one. Reduce by 2. So that will give you 5 2s are and 9s. 5 by 9. That will give you 5 by 9, or you can simply say 5 is to 9. 5 by 9 or 5 is to 9. Okay, so moving ahead, next one. If the compound ratio of 5 is to 8 and 3 is to 7 is 45 is to x, find the value of x. If the compound ratio of 5 is to 8 and 3 is to 7 is 45 is to x, compound ratio of 5 3s are 15, 8 7s are 56. It's a very simple, compound ratio is very simple. Just multiply the first to first and second to second, consequence and antecedents respectively. Okay, so this is 15 by 56 is equal to 45 by x. 15 by 56 is equal to 45 by x. So 15 ones, 15 threes. So multiply x is equal to 56 into 3. X is equal to 56 into 3. So 56 into 3, 6 3s are 18, 5 3s are 15, 16. So that will give you 168. So the value of x will give you 168. Okay, so the compound ratio 5 is to 8 and 3 is to 7 is 45 is to x. So the value of x is 168. Once again, please cross check all this. Okay, the next one, if the compound ratio of 7 is to 5 and 8 is to x is 84 is to 60, find the value of x. Again, the similar question. Compound ratio, the first to the first, 7 8 56 is to 5 into x is 5x is equal to 84 is to 60. 84 is to 60. 56 by 5x is equal to 84 by 60. 56 by 5x is equal to 84 by 60. So we can cancel with this one. 5 ones and 5 12s. Right? If I'm not wrong, 12 sevens are 84. 12 sevens, let me check that. 7 2s are 14. 7 1s are 8. So 12 ones, 12 sevens. And 7 ones, 7 8s are 56. 7 ones and 7 8s are 56. I don't think nothing is left here. So that becomes 8 by x is equal to 1. So you'll get x is equal to 8. Simply, the ratio is 8 is to 8 or it is simply 1 is to 1. Okay. So the final answer, the value of x is 8. This is in compound ratio. Once again, let me check that. Let me tell you what is compound ratio. If A is to B and C is to D are two ratios, the compound ratio is given as AC is to BD. The product of consequence and the product of antecedents. Antecedent is the first, consequent is the next. Product of antecedents and product of consequence. AC is to PD. Right? So let's try to discuss some more questions here. The compound ratio of 3 is to 4 and the inverse ratio of 4 is to 5 is 45 is to x. Find x. Compound ratio of 3 is to 4 and inverse of 4 is to 5. What is the meaning of inverse of 4 is to 5? Inverse of 4 is to 5 is 5 is to 4. Inverse of 4 is to 5 is 5 is to 4. Let me write that. Okay, 5 is to 4. So 3 5s are 15. 3 5s are 15 and 4 4s are 16. This should be equal to, given the compound ratio of 45 is to x. From there we need to find the value of x. Okay, let me do that properly. 15 by 16 is equal to 45 by x. Can we cancel 15 and 45? Yes, 15 threes. 15 ones and 15 threes. So 1 by 16 is equal to 3 by x. So x will be here and 16 into 3. 16 into 3 is 48. X is equal to 16 threes are 48. 16 threes are 48. So, okay. So that is how you can try to proceed here. Let's move for the next question. So please copy it quickly. We'll move for the next question. Now, we had discussed this unitary method previously. Once again, let us discuss what is this method about. Unitary. Unitary, the name itself says that we are discussing about a unit or the cost or the price or whatever the question is for one single item. Unit means for one single item. Okay. The method in which we first find the value of one unit and then the value of the required number of units is known as unitary method. The method of finding the required quantity for one unit, okay, finding the value of one unit, maybe one apple, one chocolate, one book, whatever it is, finding the value of one unit and then from there to get the required number of units is called unitary method. Okay, let's try to discuss from some applications on this one. Lakshmi bought 7 books for a total of 56 rupees. How much would she pay for just 3 books? Good question, right? Lakshmi bought 7 books for a total of 56. So 7 books, the total cost is rupees 56. Now, instead of directly going to 3 books, let me find what is the cost of 1 book, which is nothing but unitary method. Okay, so if 7 books cost 56 rupees, 1 book cost how many rupees? Let's take it as x and let us try to cross multiply these two. 7 into x is 7x is equal to 56 into 1 is 56. So x is equal to 56 by 7, which is 8. That means that each book cost 8 rupees. Each book cost 8 rupees. And now the question is, how much would she pay for just 3 books? For 3 books, it is 3 into 8. 3 into 8, 8 3 is 24. 3 into 8 is 24. 3 into 8 is 24, right? So that is how you can try to bring this one. Moving forward. Okay, so the next question we're having, in a primary school there shall be 3 teachers to 60 students. So there is a school where for 60 students there are 3 teachers. So the ratio is 3:30 between teacher and student. Between teacher and student, for every 3 teachers there are 60 students, not 30, it is 60. Right? It is 60, 3:60. If there are 400 students enrolled in the school, how many teachers should be there in the school in the same ratio? So let us take this as x. So this ratio is 3/60, the teacher to student. The same ratio should be followed, that is x by 400. 3/60 is equal to x by 400, right? So 1 0 and 1 0 can be cancelled. 3 1s, 3 2s. So 1 by 2 is equal to x by 40. So 2 1s to 20s. So x by 20 is equal to 1, and you can say from here x is equal to 20. You can say from here the value of x is equal to 20. Right? So moving forward from here, let's try to understand more better about this one. The income of Kumar for 3 months is 15,000. The income of Kumar for 3 months is 15,000. If he earns the same amount for a month, okay, how much will he earn in 5 months? Okay, for 3 months, if it is 15,000. For 3 months it is 15,000. Let us calculate for 1 month. That is a unitary method. For 1 month, so how much it is? It should be, let's say x. So cross multiply 3 into x is equal to 1 into 15,000. So x is equal to 15,000 by 3. That becomes a 5,000. X will be equal to 5,000, right? If we earn the same amount for a month, that is a 5,000 rupees, how much will he earn in 5 months? Okay, so for 5 months, it is a 5 into 5,000, which is a 25,000. 5 into 5,000, which is 25,000. And in how many months will he earn 95,000? So for 1 month, if he earns 5,000, in how many months he will earn 95,000? Same method, everything. Cross multiply now. Okay, so 1 into 95,000 is equal to 5,000 into x. 0 0 0 and 0 0 gets cancelled. X equal to 95 by 5. X is equal to 95 by 5. So can we divide this one? Yes, let us check that. 5 and 95. 5 1s are 5, 4, 5 9s are 45. So that will give you 0. So the value is in 19 months, he can earn 95,000 rupees. In 19 months, he can earn 95,000 rupees, right? So I hope this concept is clear using unitary method. Let's understand more about this one. Next, let's try to discuss about a percentage, a very, very important thing. Percentage. The word percent means per every 100. Per every 100 or for 100, and we discuss, we use symbol percentage. We use symbol percentage, right? The word percent means per every 100 or for 100. Okay, 1%. I said it is for every 100. So 1% is 1 by 100, which is 0.01. 1 by 100, you know, we already discussed how to convert that in decimals. As we have two zeros here, so the decimal value will be shifted towards left by 2 places and we'll get 0.01. The same way, 93% is 93 by 100, and for these two zeros, 2 decimal points will go back. That becomes a 0.93. That will give you 0.93, right? So this is about a percentage. So there are a lot many applications based on this percentage. You have a lot of questions, right? So all these we're going to discuss in the coming lecture, right? About percentages and how to compare the quantities, or how to see whether a price was decreased or increased, how much percentage of profit or loss was occurred. So all these we're going to cover in the next lecture, right? Thank you so much, friends. Stay tuned to get the next lecture. Thank you.
Hello everyone. So now we will be practicing a few questions from the chapter Some Natural Phenomena. Okay, my name is Shashan Reddy. I am a graduate from IIT Dhanbad. Let's go into the class. And there is one topic that was remaining, a very small topic that was regarding a lightning conductor. Okay, so let's learn about it. So what does lightning conductor do? It protects buildings from lightning. It will protect buildings from lightning. How does it do that? We'll explain that. Okay, I'll explain it. Don't worry. So first of all, one simple point. What does lightning prefer? A conductor or an insulator? Which does lightning prefer? Lightning prefer to go through a conductor or an insulator? Conductor, because through conductor it can easily pass. That is the reason, right? So if there is a building here, let's say this is a building, and lightning, there are chances that lightning can strike the building. Lightning can strike the building. So how do we protect this building then? What we can do is, we can attach a conducting rod to the building. And this rod, we call it as a lightning rod. That's it. But there is one small issue. What is the target of lightning? What does lightning want? Lightning will want to go from the clouds to the ground, and it will go. The aim of lightning is to reach the ground, to go into earth, So if we keep if we keep a rod only half, that is that its bottom is not touching the ground, then the lightning will enter the rod, fine, but after that it will enter the building again. We don't need that. So for that, what we will do is, we'll directly connect the rod into the ground. So lightning rod, obviously you can look at its top. At its top, it is above the building. And it will be connected directly, continuously. It will be a conducting rod. You can say conducting or a conductor, and it will be directly connected to what? Into the earth. So you'll go deep inside the ground, like 5 meters and all, and at the end you'll have a plate. So what happens is, when lightning strikes, it will strike the rod. Through the rod it comes down, and from the plate, okay, through the rod it goes into the plate. From the plate it discharges. It goes into what? Into the ground. So it spreads in every direction. Understood? So that's what happens, and that's how lightning rod protects the building. So lightning strikes, it will strike the lightning rod, it will go through lightning rod into the earth. So it does not damage the building. It does not damage the building. Yes or no? Okay. So that principle is earthing. Transferring the charge to earth is earthing. So transferring charge from a charged object to the earth is called earthing, and that's what we are doing here. Lightning has charges. We are transferring it to what? To the ground, to the earth. So lightning rod works on the principle of earthing. So remember this word, it's an important word, earthing. So lightning conductor does what? It provides earthing to the building and protecting, or it protects it from lightning strikes. It protects it from lightning strikes. So you can see, obviously in the case of lightning, what happens? Clouds get charged. It will induce a charge on what? It will induce a charge on the lightning rod. Lightning flows. It will flow through what? It will flow through the conducting rod, lightning rod, and from the metal plate it will disperse into what? Into the earth. So the building is safe. Understood? Good. So any high-rise building will be provided with a lightning conductor, will be there for sure. Safety measure. Okay? Good. Now let's go into the questions. Let's go into the practice questions. We'll start from this. The question is very simple. An object that has greater number of electrons than the protons is what? Positively charged, neutral, or negatively charged? That is the question. So I'll give you how much time? I'll give you 1 minute of time. So please solve it. 1 minute of time. So solve it, everyone. It has more number of electrons than the protons. So you have to remember what is the charge of electrons, what is the charge of protons, then add them and then decide. So please solve it, everyone. "20 seconds more." Five, 4, 3, 2, 1, and the time is up. Okay, so what is the answer here? The answer in this case, just a minute, is option C, negatively charged. Why is that? See what is mentioned here, greater number of electrons. And we know that electrons are negatively charged. Electrons are negatively charged. Whereas protons are positively charged. Protons are positively charged. And neutrons are neutral. Neutrons are what? Neutrons are neutral. Now, let's say this is an atom or an object. It has more number of electrons than protons. For example's sake, let's say there are 10 electrons and 8 protons. So there are 10 negative, I can say minus 10, and there are 8 positive, so I can say plus 8. So when you add them, minus 10 plus 8, what is that equal to? Minus 2. So if an object has more number of electrons, the total charge will be negative. The total charge will be negative. That is the reason why I go with option C, and option C will refer to what? Negatively charged. Understood? Greater number of electrons will mean the is negatively charged. Got it? Simple? Yes. Okay. Next. Two charged objects. Imagine two of them charged are brought close to each other. Choose the most appropriate statement from the following options. What are the options? The objects may attract, may repel, may attract or repel depending on the type of charges they carry, or there will be no effect. So 4 options. So which is the best option? Everyone, I'll give you 15 seconds of time. So solve it. 15 seconds. Read the options carefully. Five seconds more. And the time is up, and the correct answer is option C. Now, why is that? Because similar to magnets, charges also repel and attract. And how is that? Like charges repel. That is, if I take a positively charged body and positively charged body, they repel each other. If I take a negatively charged body and negatively charged body, they repel each other. But if I take unlike charges or opposite charges, they attract each other. What does that mean? If I take an object which is positive and if I take another object which is negative, what happens between them? They attract each other. So look at the option again. The objects may attract or repel depending on the type of charges they carry. Yes or no? If both of them are positive, they repel. If both of them are negative, they repel. But if one is positive and the other is negative, they attract each other. Simple? Good. Next. Sometimes a crackling sound is heard while taking off a sweater during winters. Explain why. Why, everyone? Write down the answer in your notes. Just write down simple points. I'll explain. What is the explanation for this? Why does that crackling sound occur? Why? When you take off a sweater, crackling sound is heard. Not always, but sometimes. Why? 10 seconds more. Three, two, one, and the time is up. Now why? Let me explain. Here, when you remove the sweater, when you try to remove the sweater, will the sweater rub against your hair? Will the sweater rub against the hair of your skin? Yes. So when you remove the sweater, this sweater rubs against the hair of your skin, the hair of your skin, the hair of the skin while removing it. And due to rubbing, what happens? Everyone, due to rubbing, what happens? They get charged because of. They get charged due to rubbing or due to friction, whatever it is. And when they get charged, small sparks occur. Right? Sparks, not dangerous, okay? Non-lethal sparks. Sparks with crackling sound occur as a result. Occur as a result. So electrostatic discharge takes place between them. I told you, right? If you have positive and negative charges, then current can flow between them in the form of electrostatic discharge. That takes place. Okay? Good. Let's continue. Next question. Explain why a charged body loses its charge if we touch it with our hand. Why? This happens in the case of electroscope also. Right? So, but why does this happen? If a body is charged and when we touch it, why does the charged body lose the charges? Yeah? And the answer will be, everyone, it is again, it is because of earthing. How earthing? Because when you touch the object, let me explain that. When we touch a charged body, the charges from it in the sense from the charged body, from it will flow into us. And through us, they flow to the ground, they go to the earth. That means, what is this principle called as? Transferring charges to the earth is called as earthing. So, we enable earthing by touching it. So, if you touch a charged object, charges can flow into our body. Where will they go? They'll go into earth. They will go into earth. Is that clear? So, earthing is a very important phenomena, very important principle. It is used in many cases. That's what is happening. Clear? Simple. Good. That is the reason why the charged object loses its charge. It loses its charges will mean the charges should go somewhere. Where will they go? They'll enter our body. From our body it goes into earth. It goes into earth. Earthing. Okay? Good. Next. An electroscope is a device which is used to find if an object is charged, magnetic, free of cracks, or hot. What do you think is the answer, everyone? Very quick. 15 seconds. 15 seconds. Please answer that. Why is an electroscope used? Very simple question, straightforward. 5 seconds more. And the correct answer is option A, charged. An electroscope, electro will refer to current or for charges. So an electroscope is a device used to detect or find whether a body is charged or not. Option A. Good? Okay. Next. Electric current is to be passed from one body to another. Electric current is to be passed. For this purpose, two bodies must be joined by, imagine two bodies, they are charged, current has to flow. So in between you have to connect to them or you have to join them. And to join them, should we use a cotton thread, a plastic string, copper wire, or a rubber band? Option A, B, C and D. What do you think? Which one should we use? Electric current is to be passed from one body to another. For this purpose, the two bodies must be joined by what? They have to be joined by? The answer is copper wire. Why? See, for charges to flow, for current to flow, it should be a conductor. And which of them is a conductor? Cotton? No. Plastic? No. Rubber? No. Copper? Yes. That is the reason. Okay? Good. Next. The aluminium strips. The aluminium strips in an electroscope, as shown in figure, we have an electroscope here, are replaced by plastic strips and a charged body is brought in contact with the metal clip. What will happen? Simple. In place of aluminium, we are using plastic strips. What will happen when a charged body is brought in contact? Very quick. I'll again give you 30 seconds of time. 30 seconds. Write it down. What happens? And I'll explain. You can compare your answer with mine. 15 seconds more. 5, 4, 3, 2, 1. The time is up. So what happens? Nothing happens. What does nothing mean, sir? See, normally what happens in an electroscope, if a charged body is brought in contact, the strips will repel each other. Yes, but that will not happen in the case of plastic. Why? Because plastic is an insulator. Plastic is an insulator, so charges cannot flow into them. Cannot flow into plastic strips. That means, see here, if the body is charged, if this is charged positive, let's say positive charges flow, then this rod becomes positive, yes, charges flow, good enough. But the charges cannot flow into plastic strips. Why? Because plastic is an insulator. Charges cannot flow into them. They do not get charged. They do not get charged, and hence they do not repel each other. They do not get charged, and hence they do not repel each other. Understood? Simple. Got it? Because plastic is an insulator, it cannot get charged. If it does not get charged, they don't repel each other. Simple. So we cannot detect whether the object is charged or not. We cannot detect whether the object is charged or not. Simple. Okay, so electroscope does not work. Electroscope does not work. Good. Next. What is the question here? How does lightning rod keep buildings safe? That's what we discussed at the beginning of the class. How does the lightning rod keep the building safe, everyone? So please, you write it down in your books, and you can compare your answer with mine. I'll give you 30 seconds, so please do write it down. How does lightning rod keep the buildings safe? Ten seconds more. 5, 4, 3, 2, 1. The time is up. Let me explain that. Okay. So first of all, simple. Lightning rod will make sure that lightning lightning strikes the rod and not the building. Lightning strikes the rod and not the building. How is this possible? Because the lightning rod is a conductor and it is placed above the building. Its height is more than that of the building. Strikes the rod and not the building. And then the lightning rod transfers the charge or the lightning. You can say anything. Transfers the lightning or charge deep into the ground, or deep into the ground, or deep into the earth. Deep into the ground and disperses it. And what is that principle? What is that process called as earthing? Through earthing. So the buildings are safe. Simple 2 points. It will make sure that lightning strikes the rod and not the building. And then it will also make sure that the lightning goes into the ground, deep into the ground, without affecting the building in any way. Got it? 2 simple steps. Take down those points. This is how lightning rod keeps the buildings safe. This is how it keeps the buildings safe. Clear? Good. So another question. During the construction of a building, the lightning conductor was left hanging in the air by mistake. Mistake. Would the lightning conductor be still effective? Explain. Read the question properly, understand that, and then say yes or no. I'll give you 30 seconds to read and understand the question. You can explain it, but first say yes or no. Would the lightning conductor still be effective? Yes or no? What do you think? "15 seconds more. First understand the question. Imagine the case. What is happening? Five seconds more. 3, 2, 1, and the time is up. And the correct answer is no. Why is it no? That's the question. Why is it no? Because see, the case is this. If this is the building, the one who has attached the lightning rod, he or she kept them hanging or kept it hanging in air. Will it be effective? Will this lightning conductor or lightning rod be effective? No. Why? Because see, the target of lightning is to reach the ground. So after coming here, after the lightning comes here, what will it do? It has to go to ground. It will go through the building. It will then go through the building again. So you're putting the building to risk. Right? The building is at risk in this case. That is the reason why it should be connected deep into the ground. It should be connected deep into the ground. So you can say lightning has to reach the ground. Lightning has to reach the ground or reach the earth. So if the lightning rod is left hanging in air, earthing is not done properly. And hence, or you can say earthing is not done properly. You can say hence, lightning reaches the ground through the building. Lightning reaches the ground through the building. Lightning will reach the ground some way or the other. If you hang it, if the lightning rod is not reaching the earth, it will go through the building. And if it goes, the building gets damaged. The building can catch fire. Building is no longer safe. Okay? Good. So next. The movement of Earth's plates causes what? Cyclones, lightning, earthquakes, thunderstorms. What does the movement of Earth plates cause? Yeah, everyone, very quick. 10 seconds. That's it. Should be enough. What does the movement of Earth plates cause? Yeah? The time is up and the answer is earthquake. What do we call them as? We call them as tectonic plates. Tectonic plates. When the two tectonic plates collide, they rub against each other, they slide over each other, all of them will lead to earthquake. Earthquake. Good. Next. Name the scale on which the destructive energy of an earthquake is measured. Very quick, everyone. What is the scale? What is the name of that scale? Not a normal length scale. No. 15 centimeter scale. No. What is that called as? It is called as Richter scale. Okay. Next. An earthquake measures 3 on this scale. Okay. Would it be recorded by a seismograph? And the answer is yes. Seismograph is capable of recording it, yeah. And only then we can get the Richter scale, or else no. Okay. Then, what is the other part? Is it likely to cause much damage? No. Magnitude 3 will mean it doesn't do much damage. Magnitude 3 earthquake will not do much damage. Will not cause much damage. As simple as that. Clear? Good. Next. An earthquake of magnitude 8 is dash times more powerful than an earthquake of magnitude 4. So I'll give you 1 minute of time for this. So please solve it. A very interesting question. I'll give you a clue. Remember that logarithmic scale. The word was logarithmic scale. Logarithmic scale. This is the last question we will be solving today, so please get it correct. "20 seconds more." Five, 4, 3, 2, 1, and the time is up. And the answer will be option D. Why is it option D? Let me explain. Okay, so first of all, understand this. On Richter scale, if the magnitude increases by 1, magnitude is +1. Okay, if it increases by 1, that means it is into 10 times more powerful. Into 10 times more powerful. Okay, so just a minute. Yeah. So if I go for, let's say, if I compare magnitude, I'll start with 4. I'll go until magnitude 5. So here it is +1. But +1 will mean what? Into 10 times. Then again, 5 to 6, another +1, again into 10. So if you combine these two, into 100, into 10 into 10, into 100. Then 6 to 7, again +1 will mean what? Again into 10. 7 to 8, another +1, again into 10. So how many times? Into 10, into 10, into 10, into 10. If I combine all of them, how many times will it be? Into 10 into 10 into 10 into 10. 10 comes 4 times, so 4 zeros. So into 10,000 times more powerful. Why is that? Because it is because of logarithmic scale. Clear? Okay. So that's it, everyone. We have practiced some interesting questions today. Right? Okay. So keep practicing. Thank you. Thanks a lot.